Let's talk a bit more about DOM access in React. One very rare but quite interesting topic there is how to change elements based on the real DOM measurements, stuff like size or position of an element. Let's take a look at what is the problem with it exactly and why useEffect hook doesn't help here, how useLayout hook can fix the problem, how it actually works, what is painting, rendering, and why we need to know all of this, and how SSR frameworks like Nextjs play a role in all of this. Let's start with the problem. Imagine you are implementing a fancy and responsive navigation component. It can render a row of links and can adjust the number of those links based on the container size. The code that renders the links themselves will be something like this. Just an array of data that we map over and render link tag. And now how to make it responsive. We basically just need to calculate how many items will fit in the available space. We need to grab the container size, all items sizes, and just do some math. And unfortunately, we have to do it. We can't just assume anything in advance here, by counting letters, for example. The size of that box in the browser will depend on so many things. On the font that is used, language, browser, and probably even the phases of the moon. That's why we have to render them first and extract that data with JavaScript. In order to do that in React component, we would create a ref and assign it to the div that wraps those elements. We would add a useEffect, extract all the sizes there, and then do the calculations to find out which item is the last visible one. And now one thing left to do is just to save that number in state, and then adjust the number of items we render based on it. This state update will trigger a re-render of navigation. React will re-render items and then remove those that are not visible during that. The code with full and working example is linked in the description. Just don't get too excited about it yet. When you refresh the page, there is a horrible flash of content. Unfortunately, we can clearly see that initial rendering of all items in a row before we remove them. But not to worry. There is a very simple trick to fix it. All that we need is to replace our useEffect hook, where we calculate those invisible items, with useLayout hook. Everything else stays exactly the same, but the problem is fixed magically somehow. But why? What is going on here? Is it safe? React docs say that it will hurt performance and we shouldn't use it. Why is that? The docs also say that it's fired before the browser repaints the screen, which implies that useEffect is fired after. But what exactly does this mean for the way I write code? Do I need to think about low-level concepts like browser paintings now? To answer those questions, we need to step aside from React for a moment and talk a little bit about browsers and good old JavaScript instead. What is this browser painting the docs talk about? The idea here is relatively straightforward. It's not drawing or painting per se. Browsers don't continuously update everything that needs to be shown on the screen in real time. It's more like they're showing slides to people, one by one. If a very slow browser was asked to come up with an instruction on how to draw an owl, it could literally be this infamous picture. Normally, modern browsers try to maintain a 60 frames per second rate, which is around 13 milliseconds per slide. The information that updates those slides is split into tasks. Tasks are put in a queue. The browser grabs a task from the queue and executes it. If it has more time, it executes another task, and so on until no more time is left in that 13 milliseconds gap. And then it refreshes the screen. But what is a task that the browser executes when it comes to normal JavaScript? Is it just one JavaScript command? Well, no. It's actually everything that we put in the script tag and execute synchronously. something like this is just one task. Notice how I changed the border 3 times here. In browser, we won't be able to see the red, green, black transition on the screen. Browser will just execute everything in one go and show us only the final result. If I add a synchronous delay after every border, all it would mean for the browser that the task will take longer than 13 milliseconds to execute. And we'll just stare at the empty screen for 3 seconds while it does it, and then see only the end result, the black border. The way to break a task into smaller, more digestible chunks is to use asynchronous methods, callbacks, event handler, promises, and so on. If I just wrap those style adjustments in setTimeout, even with 0 delay, then every one of those inside will be a separate task. And we will see the beautiful red, green, black transition, rather than just empty screen for 3 seconds and black border in the end. This is what React does for us. Essentially, React is a crazy complicated and very efficient engine that splints out giant blobs of hundreds of NPM dependencies combined with our own coding into smallest possible chunks that browsers are able to process in under 13 milliseconds, ideally. Okay, but what does it mean for our useEffect and useLayoutEffect? useLayoutEffect is the hook that React runs synchronously. Basically, it turns everything that you see here into just one task. If we look at the flow of our navigation life, it will be something like this. Initial render happens, where we generate all the items and append them to the div. Then useEffect layout is run. It changes state triggers re-render, and during re-render, we update items and hide those that we consider invisible, basically removing children from the div. All of this is within the same task. The browser just patiently waits until we're done with whatever we're doing and gives us the final result, without the invisible items. If we look at exactly the same flow, only with useEffect instead of useLayoutEffect, then we will see that initial render happens, we generate all the items and append them to div, and that's it. We're done with this task. The browser has a chance to paint the result now. Everything else will be the next task, after which the browser will paint the end result again, which in our case means deleting items. And here you go, the flash of content. And also, it should be very visible now why useLayoutEffect could badly hurt performance. It delays the very first painting, so it's definitely not your everyday tool. Use it only when you have visual glitches like we have. For everything else, useEffect is the way to go. Okay, enough about browsers and paintings. Let's return back to the code. Next step for this navigation, after the glitching is fixed, would be to use it in a real app. And it so happens that my real app is run on Nextjs. What will happen if I just copy-paste that code? It just doesn't work. The glitch is still there. What's going on? Did we mess up the code somehow? Well, no, not exactly. And it's not Next.js's fault. It's SSR, server-side rendering. You will see exactly the same problem in any framework that supports it. The problem here is React doesn't run useEffect and useLayoutEffect hooks in SSR environment, and there is a reason for it. What is SSR after all? It's just some method somewhere on the backend that calls something like React render to string on your app. React then just goes through all of your components, converts them into regular HTML, and puts it in a string. And then the backend sends that string to the browser. Here you go, you deal with it, not my problem anymore. And only then the browser converts that string into proper elements with sizes and paints them on the screen. There is no browser on the server, no elements, nothing to calculate. It's just a string. So it's pointless to run hooks like useLayoutEffect on the server. Half of the code there just won't work. And React doesn't. How to deal with it? It's user experience, not coding or framework problem. We can, for example, just render a few most important items on the server. We can try some sort of loading state, or even not render anything at all. Depends entirely on what you would consider a good user experience in your app. And from code perspective, there are a few ways to do it, but the easiest way is just to introduce some initial state when we render navigation component. We would have isReady state initially set as false. We would render some reduced experience if the variable is false, and then we would flip it to true once the component is mounted, which will happen only when the browser executes everything and all the sizes are available. So in the HTML that is coming from the server, we will see the reduced experience, and the visual flash won't be a problem anymore. All the code examples to play around with are linked in the description, along with the article on the same topic that has more detailed information and many more links. Hope this video was useful and see you next time.